Elon Musk's SpaceX is set to launch its first-of-a-kind planetary defense mission for NASA, sending the spacecraft on its way to intentionally crash into an asteroid. NASA's Launch Services Program Senior Launch Director Omar Baez said during a press conference that they are smashing into an asteroid literally, and he can't believe it's happening. NASA, in the agency's own words, is crashing a spacecraft into an asteroid on purpose. What exactly is DART? In short, it's the first planetary defense test mission, the findings of which will assist in improving on how we might prepare for an actual asteroid-related threat. Put another way, per NASA Administrator Bill Nelson, the mission turns science fiction into science fact, while again proving the agency's penchant for innovative approaches to space-focused concerns. In addition to all the ways NASA studies our universe and our home planet, we are also working to protect that home. And this test will help prove out one viable way to protect our planet from a hazardous asteroid should one ever be discovered that is headed toward Earth, Nelson added in a statement shared. Known as the Double Asteroid Redirection Test, or DART mission, the space agency is trying to learn how to deflect a threat that would come toward Earth. DART is a 610-kilogram spacecraft that will spend 10 months traveling to a pair of asteroids which are named Didymus and Dimorphos. Johns Hopkins Applied Physics Laboratory in Maryland built DART, while space company Redwire contributed to the spacecraft's navigation and solar arrays that will power it. The goal of the mission is to hit the smaller of two asteroids, Dimorphos, with a spacecraft at about 15,000 miles per hour and see how the impact changes the asteroid's trajectory. The DART mission is costing NASA about $330 million in total, with SpaceX having won the $69 million contract in 2019 for the launch. Not only is it NASA's first planetary defense mission, but DART also represents SpaceX's first mission launching a spacecraft to another planetary body. DART is headed to the Didymus asteroid system where it will slam into the 530-foot in diameter Dimorphos. Per current stats, NASA is expecting the craft to intercept the asteroid system at some point between late September and early October of next year. To be clear, NASA hasn't discovered any significant asteroid impact threat to our planet at this time. Part of the agency's larger ambition, however, is to locate any possible impact years in advance and deflect it using DART-esque tech. The headline-spurring mission is managed by Johns Hopkins University Applied Physics Laboratory for NASA's Planetary Defense Coordination Office. The Double Asteroid Redirection Test DART mission is directed by NASA to the Johns Hopkins Applied Physics Laboratory (APL) with support from several NASA centers: the Jet Propulsion Laboratory (JPL), Goddard Space Flight Center (GSFC), Johnson Space Center (JSC), Glenn Research Center (GRC), and Langley Research Center (LARC). DART is a planetary defense-driven test of technologies for preventing an impact of Earth by hazardous asteroids. DART will be the first demonstration of kinetic impactor technique to change the motion of an asteroid in space. The DART mission is led by APL and managed under NASA's Solar System Exploration Program at Marshall Space Flight Center for NASA's Planetary Defense Coordination Office and Space Mission Directorate's Planetary Science Division at NASA's headquarters in Washington, D.C. DART is a spacecraft designed to impact an asteroid as a test of technology. DART's target is not a threat to Earth. This asteroid system is a perfect testing ground to see if intentionally crashing a spacecraft into an asteroid is an effective way to change its course should an Earth-threatening asteroid be discovered in the future. While no known asteroid larger than 140 meters in size has a significant chance to hit the Earth for the next 100 years, only 40% of those asteroids have been found as of October 2021. The binary near-Earth asteroid 65803 Didymus is the target for the DART demonstration. While the Didymus primary body is approximately 780 meters across, its secondary body, or moonlet, is about 160 meters in size, which is more typical of the size of asteroids that could pose most likely significant threat to Earth. The Didymus binary is being intensely observed using telescopes on Earth to precisely measure its properties before DART arrives. To give a sense of scale, the Dimorphos asteroid is about the size of the Great Pyramid of Giza, while Didymus asteroid is wider in diameter than the One World Trade Center tower in New York is tall. After arriving at the asteroid and before it smashes into Dimorphos, the DART spacecraft will deploy a small cube satellite to take photos of the impact event. While the mission is testing a method of planetary defense, Zerbushin emphasized that NASA is not aware of any near-term risks to Earth. There are billions of asteroids and comets orbiting the Sun, but only a few have a chance of hitting Earth for a very long time. All of the near-Earth objects that we know of today, none of them are a threat within 100 years or so, Zerbushin said. The years in the making missions comes at a compelling time, as every day people are now giving renewed attention to the field thanks to separate coverage surrounding UAPs, with a focus on how that field of research is being handled at governmental level. Dimorphos orbits a much larger asteroid called Didymos. The pair are no danger to Earth, but offer scientists a way to measure the effectiveness of the collision. Dimorphos completes one orbit of Didymos every 11 hours and 55 minutes. DART's goal is a crash that will slow Dimorphos down and cause it to fall closer toward the bigger asteroid, saving 10 minutes off its orbit. The change in the orbital period will be measured by telescopes on Earth. The minimum change for the mission to be considered a success is 73 seconds. The DART technique could prove useful for altering the course of asteroids years or decades before it bears down on Earth, with a potential for catastrophe. A small nudge would add up to a big change in its future position, and then the asteroid and the Earth wouldn't be on a collision course. The DART spacecraft will achieve the kinetic impact deflection by deliberately crashing itself into the moonlet at a speed of approximately 6.6 kilometers per second, with the aid of an onboard camera named Draco and sophisticated autonomous navigation software. The collision will change the speed of the moonlet in its orbit around the main body by a fraction of 1%, but this will change the orbital period of the moonlet by several minutes, enough to be observed and measured by using telescopes on Earth. Once launched, DART will deploy Rollout Solar Arrays, ROSA, to provide the solar power needed for DART's electric propulsion system. The DART spacecraft will demonstrate the NASA Evolutionary Xenon Thruster commercial. Next-C, Solar Electric Propulsion System, is part of its in-space propulsion. Next-C is a next-generation system based on the Dawn spacecraft propulsion system and was developed at NASA's Glenn Research Center in Cleveland, Ohio. By utilizing electric propulsion, DART could benefit from significant flexibility to the mission timeline while demonstrating the next generation of ion engine technology with applications to potential future NASA missions. The DART spacecraft launch window begins November 24, 2021. Scientists constantly search for asteroids and plot their course to determine whether they could hit the planet. Lindley Johnson, Planetary Defense Officer at NASA, says that although there isn't a currently known asteroid that's on an impact course with Earth, we do know that there is a large population of near-Earth asteroids out there, and the key to planetary defense is finding them well before they are an impact threat. DART will take 10 months to reach the asteroid pair. The collision will occur about 6.8 million miles or 11 million kilometers from Earth. 10 days beforehand, DART will release a tiny observation spacecraft supplied by the Italian Space Agency that will follow it. DART will stream video until it is destroyed on impact. 3 minutes later, the trailing craft will make images of the impact site and material that is ejected. The DART team won't be twiddling its thumbs until the big collision, of course. Every space mission is packed with milestones, which tend to come fast and furious in the few weeks after launch. For example, DART is now in the commissioning period, a 30-day stretch just after liftoff in which the mission team members are checking out spacecraft's various systems and its main scientific instrument, a camera called Draco, which means Didymos Reconnaissance and Asteroid Camera for Optical Navigation. Another big moment will come about 20 days into the flight, Adams said, when the DART team will fires up NASA's Evolutionary Xenon Thruster commercial, Next-C engine, which was developed by the agency's Glenn Research Center and the aerospace company Aerojet Rocketdyne. Next-C is a solar-powered ion propulsion system that could find its way into future spacecraft. It's not DART's primary propulsion system. The probe is using a set of 12 hydrogen thrusters to make its way toward Didymos and Dimorphos pair. But Next-C will get a key in-space test during the mission. Elena Adams, DART mission systems engineer at the Johns Hopkins University Applied Physics Laboratory in Maryland, said during a pre-launch news conference on November 4th that the action will ramp up considerably as DART nears its target. Draco will capture its first imagery of the Didymos system 30 days before impact. Those photos will help the probe refine its course toward Dimorphos. Then 10 days before impact, DART will deploy a tiny Italian spacecraft called Lycia Cube, which will zoom past Dimorphos just after the collision to observe its immediate effects. Those effects could be quite striking, given that DART will slam into Dimorphos at about 15,000 miles per hour or 24,000 kilometers per hour. The impact will occur when the Didymos system is roughly 6.8 million miles, or 11 million kilometers from Earth, about the closest the two asteroids get to our planet on their elliptical path around the Sun, and that's no coincidence. DART will launch aboard a SpaceX Falcon 9 rocket from Vandenberg Space Force Base, California. After separation from the launch vehicle, the DART spacecraft will intercept Didymos moonlet in late September 2022 when the Didymos system is within 11 million kilometers of the Earth, enabling observations by ground-based telescopes and planetary radar to measure the change in momentum imparted to the moonlet. SpaceX test-fired its Falcon 9 rockets recently in preparation for the launch. Now that you've watched the video, let us know what you think about DART. Thanks.